Okay, so looking into Chapter 7, this is about the reconstitution of medications. Okay, so just a brief idea here of what we're doing. If you're going to, okay, switching gears, sorry. The medications, the liquid medications that we get are often not usable after a certain amount of days, right? Like if you've ever seen any of your, like, I always think back to when my girls have earaches, we get amoxicillin. Well, it tells me on there, keep it in the fridge and discard after 10 days. It's not very efficient to have a medication that's going to wear off after 10 days, okay, or stop being effective after 10 days. So whenever you're looking at liquid medications, a lot of times they will come in powder form that have to be mixed with some kind of liquid to get them into that usable state, like I would give my 2-year-old with her earache. Okay, so that powdered form is a lot more stable, is the word that they use. It has a longer shelf life, basically. Okay, so it comes in a powder format, and you've got to mix it with some kind of liquid to get it into a usable state. That process of mixing it with the liquid, that's called reconstitution. Right? So it's sometimes like if you're thinking about mixing up that powdered lemonade, okay, or a Kool-Aid or whatever. You take that powdered form, mix it with water, and dilute it down into something that is more usable, okay. So let's look at some vocab words here. The diluent is a fluid that makes the mixture less concentrated. It dilutes the mixture, okay. So this is the water that you add to the Kool-Aid powder, the diluent. The dilution is the extent to which the concentration of a mixture is reduced. Okay. Sometimes you will be asked to dilute something like, let's say you're in a nursing home setting and those little Ensure milkshakes that they drink that have all their proteins and all their vitamins and stuff. Those are pretty thick. And some of your older people have trouble swallowing liquids that are that thick. So they'll ask you to dilute it down to a 50-50 concentration, okay, or a 1-to-1 concentration. So that's what this is talking about, the dilution, the extent to which the concentration is reduced. The dilution ratio is the number of parts of active ingredients to the number of parts of inactive in a solution, okay, and we're going to talk some more about that at the end of Chapter 7. Displacement. This is the volume that has been occupied by powder whenever the diluent has been added during reconstitution. So I remember back when I was mixing up formula for my babies, that I would add the scoops of powder I would fill the bottle up with, say, 60 milliliters of water, and I'd add in my 2 scoops of powder, or whatever it was, and whenever I get done mixing it, shaking it all up, now all of a sudden I had 70 milliliters of fluid. I only put 60 in there. Okay, that extra little 10 milliliters is the displacement. Okay, that's the volume that's occupied by the powder. Reconstitution, this is the process of combining a dry form or something that's really concentrated, some liquid, with a fluid to achieve a usable state. Okay. More vocab. A solution concentration is the amount of drug in a quantity of solution expressed as a ratio. And we've looked at this before. This is where they write it on the label that there's 100 milligrams per 100 milliliters or whatever. Okay. Suspension is one of those abbreviations I think we looked at way back in Chapter 4. But this is a liquid where there are fine particles of medication that are dispersed through a fluid. It's supported by buoyancy and shaking or stirring. So you've ever seen any kind of liquid medication that says shake vigorously before giving? Well, that's why, because all the medication settles to the bottom of it, and you've got to shake it back up to get it suspended within that fluid. SW is another abbreviation you need to start memorizing. This stands for sterile water. Okay, that's one that it's a diluent that we use to mix into powders. There's also bacteriostatic sterile water, and you can do that with a BSW. This is sterile water with extras. Okay, it has an antimicrobial agent maybe such as benzyl alcohol. Okay, so bacteriostatic sterile water. It's not the same as sterile water. It's got a few additives in there. Unit. Here, we talk about our milligram, microgram, milliliter, all that stuff is we refer to as the units, okay? But sometimes they will also measure medication in just units and not grams or milligrams or micrograms. They'll just tell you, 15 units of insulin or 4,800 units of heparin, okay? So it's just a standardized lab measurement that measures the therapeutic strength as opposed to weight or volume, okay? So you'll see it used with heparin, insulin, antibiotics sometimes. They'll just, it'll tell you a certain number and it'll have the word unit beside it instead of the number with a milligram or a number with a milliliter. It'll just be a number with the word unit beside it. Unstable. This is not that it's going to blow up on you or anything like that. When we say a substance is unstable, that just means it's easily broken down into a state of diminished effectiveness. Okay, so you know how the glow sticks that my kids play with, they're good for a couple hours, right? But whenever they go to bed, they wake up the next day, they're not glowing anymore. Okay, they're unstable at that point. They just their effectiveness just kind of fades away. Okay. All right. Let's look at some basic information. We said medications are supplied in dry form, and then they are reconstituted by adding liquid shortly before you use them. Okay. Some medications are considered unstable in liquid form, and that's why they need to be reconstituted just before you use them. So, unstable just meaning that they're going to deteriorate quickly. The dry medications can be stored for a long time, but solutions have a short shelf life after they've been reconstituted. Whenever you're looking at the label for these diluents, okay, or the label for the medication that you're fixing to mix in, it will have all the types of directions and storage and which one of these diluents you need to use. Okay, those labels will tell you a lot of information. We're going to look at some of those later in this chapter. So a lot of information is on that label. You can see here I've got a label for bacteriostatic sterile water, 30 milliliters. I've got a label for a sterile diluent, just sterile water. Okay, so that one's a 20 milliliter. But those are two different diluents there. That bacteriostatic sterile water has that benzyl alcohol. I think it even tells you that. Yeah, 0.9% benzyl alcohol has been added. Okay, so like I said, be sure you're reading all your labels whenever you're looking at your powder that you're fixing to mix some medication in. This one even gives you different strengths. If you want to mix it to a 3,000 something per milliliter, okay, it tells you the directions for that versus a 5,000 versus a 10,000. Okay, and we're going to look at picking out those different strengths later in this chapter too. Hopefully, whenever we get back to the classroom. Reconstituting those sterile meds. So, if you're working with the sterile medications, those are usually ones that are going to go into a vein of some sort. A lot of your oral medications don't have to be sterile. And I'm not talking just cleanliness here. Okay, sterile filled as in, gowned up, gloves on, all that sterile field stuff. But you're going to have the little vials, okay, and you're going to use an appropriate size syringe and needle that's going to hold the total volume. And you're going to add the diluent, the fluid, into the medication and gently roll that vial until all the bubbles are gone. Okay. I've got another example here that it comes with some little extra stuff. You've got your vial with the powder in it. You've got some alcohol swabs. You've got the vial with the diluent in it. You've got the sterile disposable syringe, say like a 3 ml syringe. You've got the needle for withdrawing the diluent from the vial, And then you've got your sterile disposable syringe that you're going to use the needle for the sub-Q injection. Okay, so it takes a lot of different little equipment to just mix up some medication. Alright, example 1. Let's say we have this label, and I'm going to make it bigger for you. But let's say we have this label that we are asking all these questions about here. So, amoxil. We want to know the form and the route of the medication. Hang on. I wonder if I can do this any differently here. Hang on, let me play around with this. Okay. I'm hoping you can see that a little bit better than what I had on the previous slide. So, let's say we've got this amoxil label, and I'm going to ask you the questions about it and show you where it's coming into play at. So, first part, what is the form and the route of the medication? What is the form and the route of the medication? So, you see here under the name that it's talking in purple for oral suspension. Okay, suspension is the form, and oral is the route. Okay, so we can just answer oral suspension. Next question. What type of diluent do we need to use? So over here on the side, it's talking to you about directions for mixing. It says tap the bottle until all the powder flows freely. Add approximately half. What this says? No, a third. Add approximately a third of the total amount of water for reconstitution. And it says a total of 78 mils. Shake vigorously to wet the powder, and then add the remaining water. Shake vigorously again. So, anyways, it's talking about what type of diluent are we going to use? Well, just water. That's all it says that we have to add, right, is just water. So that can be water out of the tap. It doesn't have to be sterile water. This is an oral suspension. Okay, they're just going to drink it. So water out of the tap is fine. What is the total amount of diluents that we need to add to the bottle? So you remember here in the parentheses it says total 78 mil. That's the total amount that you're going to add to this. Next question asks, what are your mixing directions? Well, it's all of this. I mean, it's all this from tap the bottle until all the powder flows freely, add approximately a third amount of water to reconstruct, your total is 78 mils. It's all that stuff, all the way down to add the remaining water, again, shake vigorously. Okay, all that is your mixing directions. Now, I want to talk to you about this, add approximately a third of your total amount. Okay, let me slide this screen back over here so you can see what I'm talking about here. So, our mixing directions, can I make that bigger? I guess so. Anyways, this is the part I wanted you to see. We said we had a total of 78 mils, right? And we only need to add a third of it to start with. So all you've got to do in your calculator is do 1 divided by 3 times 78. And that should tell you 26 mils. So that's going to be your first mix. You're going to add 26 mils into the powder and shake vigorously to wet the powder. But we're not done. Okay. After that first one, then we go back in and add the rest. Okay, so we need to do 78 total. We've already used 26 of it, so that's going to leave you with 52 milliliters. So at that point, you'll add in the 52 milliliters and then shake vigorously again. Okay. Next question wants to know, what is your drug concentration after reconstitution? So let me slide you back over here to the label. I apologize for this. Okay. The drug concentration after reconstitution. Well, is it in here somewhere? Each 5 mil will contain amoxicillin tetrahalide equivalent to 125 milligrams. Okay. It's also what it tells you up here in the purple. A little bit easier to find. 125 milligrams is 5 milliliters. Okay. That's the concentration after it's been reconstituted. Each 5 milliliters is going to have 125 milligrams. Now, I did want to point out this 100 milliliters down here. It says it's going to have 100 milliliters once it's been reconstituted. Okay, so again, it comes in powder format, you're going to add 78 mils to it, and then it's going to have 100 mils